The FilClean CMS system has 3 tanks. Tank A, which holds brand new coolant, Tank B, which holds reclaimed filtered coolant, and Tank C, which holds dirty coolant, before being pumped into Tank B for reclaim. Tank A contains freshly mixed coolant, blended by an onboard proportioning pump shown here. The proportioning pump, which is energized by pressurized water, pulls the coolant concentrate from a customer-provided container, and then blends it with the same incoming water which powers the pump. Pump mixing ratio of concentrate to water is simply adjusted by the operator by turning a set screw on the pump. For a deeper understanding of Tank A's filling process, please refer to this detailed animated schematic here. Tank levels in both Tank A and Tank B are regulated by the auto balance controller, which receives signals from each tank's ultrasonic level detectors. To ensure fail-safe operation, pressure transducers in each tank also measure levels and serve as high and low level backups to alarm and prevent overfilling or underfilling. When the auto balance controller determines levels in both tanks are optimal, the controller opens the emergency backup main normally closed water solenoid. Subsequently, the solenoid controlling the incoming Tank A water supply also opens, directing water to the proportioning pump. Pressurized water now flows to the proportioning pump, energizing it. Following the previously outlined process, the pump then pulls coolant concentrate from a customer-supplied container, blends it with the incoming water, and delivers perfectly mixed coolant into Tank A. Once Tank A reaches its pre-programmed level, the incoming Tank A water supply solenoid shuts off until the level drops sufficiently after providing a 24/7 on-demand supply of new coolant to the customer's process. Tank B reclaimed coolant levels are also controlled by the auto balance control system and installed ultrasonic level detectors and pressure transducers. When the level in Tank B is low enough and the level in the inlet Tank C becomes high enough, a compressed air-driven diaphragm pump shown here pulls coolant out of Tank C through a 25-micron bag filter for pre-filtration, and then pumps it through 2 large 30-micron cartridge filters for polishing. Then, when level in Tank C drops to a pre-programmed value, the electric 3-way valve shown here switches to Tank B coolant recirculation as shown. While that is happening, the Tank B blending pump shown here recirculates coolant in Tank B and sends a partial side stream of coolant passing across a supplied inline refractometer to constantly measure the reclaimed coolant's concentration. If the concentration is out of specification due to water evaporation, then an operator-programmed amount of water is automatically batch injected into Tank B to compensate. Then, after a pre-programmed amount of recirculation time to allow for blending, the concentration is checked again, and if needed, more water is added in batches until the operator's pre-programmed concentration value has been met. Finally, based on a 24-volt signal from an external customer-supplied level control, coolant may be pumped out to the customer's process using the outlet pump shown here, from either Tank B or Tank A, based on the set direction of the outlet electric three-way valve shown here. Tank B Reclaim is the default customer coolant supply, unless its level is too low or the coolant concentration value is out of specification. When this happens, Tank A becomes the default supply until that is rectified. For a more detailed understanding of the Tank B reclaim process, please follow along with the following animated schematic. When the Tank C ultrasonic level detector indicates that coolant in Tank C is high enough, and the ultrasonic level detector in Tank B shows coolant levels are low enough, the electric three-way valve shown here will switch to Tank B pump-in mode, and then a 24-volt air solenoid shown here will open, sending compressed air to the air diaphragm pump. The air diaphragm pump will then pull coolant out of Tank C through a 25-micron bag filter for pre-filtration, and then pump it into 2 large cartridge filters for polishing before entering Tank B. Once level in Tank C drops low enough, or level in Tank B is high enough, the electric three-way valve shown here will then switch to Tank B recirculation mode. Then the Tank B coolant recirculation pump engages, recirculating coolant in Tank B with a small side stream passing across the inline refractometer shown here. If the coolant concentrate in Tank B is higher than the set point in the auto balance controller, the Tank B 24-volt inlet water solenoid will open, sending water into Tank B for dilution. A flow totalizer shown here will then measure a pre-programmed amount of water and then shut off Tank B 24-volt inlet water solenoid when that amount has passed across it. Then, after a programmed set amount of time has passed to allow for water and coolant blending in Tank B, the coolant concentrate will be checked again, and more water may be added in further batches until the operator pre-programmed coolant concentrate set point is reached. After that, the outlet three-way valve will switch so that Tank B is online to supply coolant to the customer's process, until either the level drops too low or the coolant goes out of concentration specification again. When that happens, Tank A will be online until Tank B is back in specification. The auto balance control system provides all controlling, monitoring, and alarm functions for the FilClean CMS system, with the exception of the coolant concentration value in the new coolant Tank A, which, as previously stated, needs to be set manually on the proportioning pump. The auto balance features include Tank A, B, and C level indications shown on the front home panel touchscreen, real-time Tank B coolant concentrate level indication, indications of both the inlet and outlet three-way valve set directions. The auto balance controller also indicates any alarm and maintenance functions via both an audible buzzer and visual stack light. Alarms and maintenance indications include bag filter plugged indication, which means the bag filter must be replaced. Cartridge filter plugged indication, which means cartridge filters must be replaced. Tank A, B, high, and low alarms. Refractometer signal error, which means a signal has been lost from the refractometer, either due to malfunction or loose wire requiring rectification. Water flow error, meaning no coolant concentrate rebalance water, has been sensed by the flow totalizer, which means either a malfunction or loose wire requiring rectification. A manual mode feature is also included with the auto balance control system, which allows operators to manually energize every solenoid and pump for either testing purposes or for manual tank A, B, or C pump out capability. The auto balance controller also features a setup screen where high and low level control values may be entered manually to control the maximum and minimum levels of coolant allowed in both tank A and B, and the maximum level allowed in tank C. The setup screen also allows for calibration of the inline refractometer, which is required when first starting up the FilClean CMS system on a different coolant than previous. For further details on recalibrating the inline refractometer, the auto balance control system, or the FilClean CMS system in general, please reference the detailed operations manual included with the unit. And thank you for watching.